This is part 2 of lesson 4, network security threats and issues. We begin by talking about malware, malicious code. There are several different distribution methods to cause malware to be placed on your system. They can be done by way of software downloads, email, malicious websites, file transfer, or flaws in software. The effects, of course, include data loss, exposure or change, poor system performance, pop-up ads, or your system could become a bot or a zombie. There are many different types of malware. The most common are viruses and worms, Trojan horses, keystroke loggers or keyloggers, spyware and adware, rootkits, logic bombs, trapdoors and backdoors, URL injectors and browser redirectors, and exploits. Viruses and worms. Viruses infect boot sectors or files such as executables, drivers, in your system. They need user interaction to spread. They spread the file to file upon opening. They may spread to other systems through email or network shares. But the main thing about a virus is that it is spread by you committing a discrete act, in other words, opening a file, typically by opening an attachment to an email, but opening any file that contains a virus will cause it to spread onto your system. Worms infect systems. They don't need your interaction to spread. They can be carriers for other types of malicious code. Typically, they scan the system for flaws and exploit the flaws to infect other systems, and generally they go along a path of a network, infecting all of the computers, all the nodes on that network. Trojan horses, the delivery method for a malicious payload, usually appear to be a benign program such as a game or utility installed by users without the knowledge of the malicious payload, and they allow remote access to attackers. And of course, the phrase Trojan horse comes from the famous story of Helen of Troy, where all the soldiers were inside the Trojan horse, wheeled into the fort, they opened up the horse, and all the soldiers came out. So the idea here, of course, is that it appears like it's a valid program or a valid software utility, and then you download it, and unbeknownst to you, out comes the virus or the malware that gets loaded onto your system, and you don't even know what happened. Keystroke loggers, also called keyloggers. These are software-based keyloggers, can be installed by way of worms or Trojan horses. They record the keystrokes and transmit them to the attacker by way of looking at email or file transfer protocol or instant messaging. Obviously, what they're looking for? Well, a lot of different things. They could be looking for your user ID and your password. They could be looking for various other security credentials as you key them in. And of course, they could be looking for 16 digits, which would be a MasterCard or a Visa. Or they could be looking for 15 digits and recording those, which would be American Express. There are hardware-based keyloggers. They're in line with a keyboard cable, or they can be actually placed inside the keyboard. Spyware and adware. Spyware monitors and records user activities like keylogging software, transmits information back to the originating author. Adware is similar to spyware, delivers advertising through pop-ups, email, or browser redirection. They may be bundled together, or they may be embedded in other programs. They may masquerade as anti-malware products. An example would be Bonzi Buddy, Gator Gain, Adware, and AdVirus 2008. Rootkits, codes that position themselves between the operating system kernel and the hardware. They allow the attacker to gain root administrative access to the system. They can be used to take control of a system, hide data files, and hide other malware or hacker tools, and they are very hard to get rid of. A lot of times they get positioned inside the registry, which means it becomes very difficult to go in there and find the right key to get rid of the rootkit that's been loaded onto your system. Logic bombs, malicious code that lies dormant until triggered. There are various different triggering events: time and date, program launch, keyword, accessing a URL. Backdoors and trapdoors. These are synonyms for the same type of malware. They bypass normal authentication or security controls. They may allow the attacker to gain remote access to the system, alter files and system settings, install hidden software, gain control of the system, turn the system into a bot, use the system to send spam. Examples include Back Orifice, early Microsoft Windows program designed for remote access and administration, but also had malicious properties, and the MyDoom virus, which installs a backdoor on the infected computer. Malware URL injectors and browser redirection, also called browser hijacking. They replace the URLs with alternative addresses. They may redirect the browser to the target website. They may also change the browser homepage, which can be very annoying, especially if you click on some kind of search engine, accidentally download the search engine to your system, not the one you normally use, and all of a sudden now your homepage has been changed to the homepage of that search engine. They may prevent access to anti-malware websites, which is another problem. And they may inject entries into the host's file, and other malware may contain URL injector code. The browser redirection is a real problem. Exploits take advantage of flaws or bugs in the software, including code bugs, timing, communication issues, and storage. They're often embedded in other forms of malware, and they may be standalone or part of hacker hacker toolkits. The advanced persistent threat, highly targeted, targeting intelligence often gleaned from other types of attacks, such as phishing or social engineering. The occurrence has increased dramatically, but still represents a small percentage of all attacks. The impact of malware on organizations. The Melissa virus, which was quite some time ago now, caused $80 million in damages in North America. The SQL Slammer virus caused $1 billion in damages and made Bank of America ATMs unavailable. Continental Airlines flights were delayed or canceled because of this. Code Red infected 300,000 plus computers in a denial of service attack, and Cisco DSL routers stopped forwarding traffic. Application vulnerabilities. Buffer overflow. This is where the injection of more data than a memory buffer can hold. Injection of more data into that buffer may result in arbitrary code execution, some kind of code that's going to do something to your system that you did not expect. Cross-site scripting and SQL injection. SQL injection inserts code by way of unsanitized data input on websites, allows access to back-end databases. Cross-site scripting, attackers insert client-side scripts into web pages and allow malicious scripts to be run in the user's context. Cached credentials. Credentials stored on a local machine, for example browser cache, can be discovered by and reused by an attacker. Mitigating application vulnerabilities. In-house coding. Implement secure coding practices. Ensure that only data that is supposed to be entered into a field is entered. In other words, edit checks on data so that other data values unacceptable data values cannot be entered into a system. Also ensure that edit checks exist so that numerics cannot be that alphas cannot be keyed into a numeric field. Include security in the software development lifecycle and perform testing and quality control. For operating systems or applications, keep abreast of the vulnerabilities. Check the National Vulnerability Database, the U.S. CERT Vulnerability Notes Database, www.kb.cert.org/VULS. Security Focus, www.securityfocus.com, and apply patches and updates in a timely manner. Perform vulnerability scanning. And you should consult the Open Web Application Security Project, or OWASP, for web application security, a very, very good tool and a good resource for web application security. Indeed, it's been used in ITEC 5001 and Cybersecurity 1 before. What is risk? Risk has several meanings: danger, consequences, or likely a probability of something happening that's bad. Definition of risk or an informal risk assessment, a measurement based on the relationship between the likelihood of it happening and its impact. You have to have a methodology to identify risk, to assess risk. And first you must perform identification, including identifying your assets, the threats, the vulnerabilities, and existing security controls. Perform analysis. Identify threat vulnerability pairs by matching threats with vulnerabilities to create exploit scenarios. Analyze the effectiveness of existing controls. Determine the impact of a successful exploitation, and determine the likelihood of a successful exploitation. Determine the risk for each threat vulnerability pair using a matrix, and then use the results to prioritize your mitigation efforts. Measuring risk. Risk equals the impact times the likelihood. Impact is the consequence of a successful exploitation of a vulnerability. In other words, it could be financial, could be the loss of reputation, could be failure to comply with regulations. The likelihood is how probable is it that an impact will occur. Risk can be measured. Qualitatively it's either considered low, moderate, or high. Quantitatively, it's a numerical value. IT risk assessment is usually qualitative because it's difficult to obtain quantitative values. Here, a good example of qualitative versus quantitative would be insurance. Insurance companies use actuarial data in order to quantitatively determine risk for the purpose of setting rates. For example, if one lives in an area prone to natural disaster, homeowners insurance rates will be higher than for those who do not. If one lives in a high crime area or has a make and model of car that is popular to steal, then auto insurance rates are higher than if one lives in a low crime area and has a vehicle unattractive to thieves. Insurance companies have access to actuarial data that allow them to put a number to likelihood, and the impact is the financial loss of the property. IT does not have the same type of actuarial data, and it's difficult to put a dollar value on many of the impacts that can be caused by a successful security incident. Impact is often more than just financial loss. It can involve reputation, employee morale, customer satisfaction, or regulatory issues. It may also depend on the industry, the type of data, and where in the world the data is stored, processed, and transmitted. There are other qualitative components, such as what is important to management, that cannot be addressed in a quantitative risk assessment. Here we see the risk matrix, likelihood, and then impact. Obviously, if the impact on the system or your assets is high and the likelihood is high, that's going to be critical. If it's low and low, that's going to be low, and then they have the medium in between. And it's up to each organization to determine where their risk falls in this matrix, based on the likelihood of a vulnerability being exploited and based on the impact of that exploit on the organization. In summary, we talked about what you need to protect and from whom, risk assessment for network infrastructure, wired and wireless network infrastructure risks, threats, and vulnerabilities, common network hacking tools, applications, exploits, and attacks, and social engineering practices and their impact on network security efforts. This concludes Chapter 4.